So far, we've spent a lot of time trying to figure out what antiderivatives are and computing them. Why did we want to do that? Because ultimately we want to compute definite integrals. Now, we've already looked at definite integrals using our calculator, but here we want to get the exact answer. The answer given by calculator is only an approximate answer. So how do we do this? Well, we're going to use the fundamental theorem of calculus combined with our antiderivative. That is, this definite integral is going to be equal to f of b minus f of a, where f is an antiderivative. That's what the fundamental theorem of calculus tells us. In other words, the total change is going to be given by the integral of the rate of change, because since capital F is an antiderivative, little f is the derivative of f, right? So capital F prime is equal to f. So little f is a rate. So the total change can be represented by this definite integral, or it can be represented by this difference. Okay, so we're going to use that to compute things like this. So how does that go? Let's look at an example. Let's compute this. This is the integral from minus 1 to 1, t squared plus t dt. So this is different than an indefinite integral because I have my limits of integration, minus 1 and 1. So how do I do this? Well, the basic step is to first compute an antiderivative, for this is going to be my function f. What's an antiderivative of that function? It's going to be t cubed over 3 plus t squared over 2. So then the fundamental theorem of calculus tells me that this definite integral is the same as f of 1, that's my b, minus f of a, which is f of minus 1. So I plug in my endpoints into the antiderivative and take the difference. Okay, well, to find out what f of 1 is, I plug it into this formula for my antiderivative. I get 1 cubed over 3 plus 1 squared over 2. So that's this first part. And then I subtract from that the evaluation at the other endpoint. So I plug in minus 1 into f this time. So minus 1 into f gives me minus 1 cubed over 3 plus minus 1 squared over 2. Now, it's very important to remember these parentheses. These parentheses, otherwise, when you subtract, you'll actually get the wrong sign on the second term. So very important, use parentheses when you do this minus sign. Okay, and then you can evaluate this just by usual business. 1 cubed is 1, 1/3 plus 1/2 minus, and then parenthesis, minus 1 cubed is the same as minus 1, so that's minus 1/3, plus, and then minus 1 squared is 1/2. Okay, and then if you work it out, 1/3 minus minus makes a plus 1/3, so that's 2/3, and then 1/2 minus a 1/2 makes 0. So the answer is 2/3. Now you could have gotten this with your calculator, but in your calculator would have given you the answer 0.666666667 or something like that, which is only approximation, right? This is not the exact answer. The exact answer is 2/3. This is just an approximation of 2/3. And that's going to be important, especially in exam problems, and we'll see that later. Okay, so this is one way to think about it. There's actually a more standard method for computing this, and let's redo this problem using that standard method. Okay, so the way that normally one approaches this is one just tries to find the antiderivative. That's what the integral sign tells us to do. So we write it as t cubed over 3 plus t squared. I'm just redoing the problem, but in a simpler way. So that's the antiderivative, and then we put this little bar here. And what that bar tells us is we're going to use the fundamental theorem of calculus, meaning that we're going to plug in minus 1 and 1 and take the difference. That's all this means. So when you write this, you find the antiderivative, and then instead of writing the integral sign on the left-hand side, you write this bar with the same limits on the right-hand side. So that's equal to this, and then this bar means plug in 1. So I get 1 cubed over 3 plus 1 squared over, that's a 2 over 2. And then I plug in my minus 1. So that's minus 1 cubed over 3 plus minus 1 squared over 2. And that stays on the right-hand side. I still use parentheses, same expression as before. It's just a shorter, quicker way of doing the fundamental theorem of calculus and getting the expression. And then you evaluate just like before, and you get 2/3. Okay, and we'll do more examples later.